In the silent, interwoven tapestry of the cosmos, where filaments of dark matter stretch across billions of light-years, galaxies cluster like jewels sewn into black velvet. They gather in great cosmic cities, gravitationally bound communities humming with the light of a trillion suns. One such metropolis, the Perseus cluster, lies 240 million light-years from Earth. It is an ancient and violent place, a sprawling kingdom of 1,000 galaxies, all swirling in a celestial dance choreographed by gravity. The space between them is not empty, it is filled with a searingly hot, ethereal gas, a ghostly atmosphere heated to millions of degrees by the ceaseless motion and collision of its galactic citizens. Here, in this cauldron of creation and destruction, the rules of the universe are written in fire and shadow. Most of these galaxies follow a predictable pattern, a delicate and fundamental covenant between the light of their stars and the darkness at their core. For every 1,000 units of stellar mass in a galaxy's central bulge, there is, on average, 1 unit of mass locked away in its central supermassive black hole. It is a cosmic symbiosis, a balanced partnership where the galaxy and its monstrous heart grow together over cosmic eons. But deep within the tumultuous heart of Perseus, there is an outlier. A rebel. An object so profoundly strange it forces us to question the very laws we thought we understood. It is a galaxy named NGC 1277, and it is a ghost from a forgotten age. From a distance, it appears unremarkable, a small, dense, reddish lens of light, a quiet bystander in a chaotic neighborhood. Yet, this placid appearance conceals a gravitational secret of terrifying proportions. At its center lurks a black hole so colossal, so impossibly dominant, that it shatters the cosmic covenant. It is not a partner to its galaxy, it is a warden. This single object accounts for more than half the mass of its galaxy's core, a statistical impossibility that should not exist. It is as if we discovered a human being whose heart was heavier than the rest of their body combined. This is the story of a cosmic relic, a galaxy that died almost as soon as it was born, and the monstrous engine of gravity that both created and condemned it. How could such an imbalance arise? What ancient, violent history does this silent galaxy conceal, and what does its existence tell us about the very dawn of time? We invite you to journey with us into the crushing depths of the Perseus cluster, to confront a shadow that outweighs its own light, and to unravel the mystery of the galaxy that is almost entirely a black hole. Now, let's begin. Music. To understand the anomaly of NGC 1277, we must first understand its home. The Perseus cluster is not merely a collection of galaxies, it is a living, breathing, and profoundly violent ecosystem. It is one of the most massive objects in the known universe, a gravitational well so deep that it pulls matter toward it from hundreds of millions of light-years away. Imagine a cosmic city, not of steel and light, but of stars and nebulae, where the inhabitants are entire galaxies, each containing billions or even trillions of suns. The gravitational pressures here are immense. Galaxies do not drift serenely, they are hurled through the intra-cluster medium at incredible speeds, like cosmic cannonballs. Their paths cross, they sideswipe one another, and sometimes, they collide in spectacular, cataclysmic mergers that last for hundreds of millions of years. These interactions are transformative. They tear spiral arms from beautiful, pinwheeling galaxies, leaving them bruised and distorted. They trigger furious bursts of star formation as vast clouds of interstellar gas are compressed and ignited. And through a process known as galactic cannibalism, larger galaxies consume their smaller neighbors, growing ever more massive over the eons, their central black holes feasting on the influx of new stars and gas. The space between these giants is filled with the aftermath of this eternal conflict. The intracluster medium, that superheated gas visible only in X-rays, is the spectral remnant of galactic atmospheres, stripped away by the sheer velocity of their passage or blown out by supernovae. It is a diffuse, trillion-degree graveyard of lost potential, a testament to the cluster's brutal environment. Within this environment, survival depends on adaptation. Galaxies merge, grow, and change. But NGC 1277 did none of these things. It exists within this maelstrom as an object seemingly frozen in time, a relic untouched by the chaos that surrounds it. This is our first clue. Its isolation is not one of location, but of interaction. It is a ghost at the feast, present but not participating. To find it, our gaze must sweep past the cluster's brilliant, dominant central galaxy, NGC 1275, a beacon of chaotic star formation and energetic jets. We must look into the churning heart of the cluster, where the galactic density is highest, and find the small, reddish, almost featureless glow of NGC 1277. It is classified as a compact lenticular galaxy, a lens-shaped disk of stars without the grand spiral arms of a galaxy like our own Milky Way. Its color is a profound giveaway. The reddish hue speaks not of vibrant, glowing nebulae where new stars are being born, but of an ancient, dying population. Its light is the tired, fading ember glow of old, red stars, celestial bodies that have been burning for 10 billion years or more. There are no brilliant, hot blue stars here. There is no gas, no dust, no raw material for creation. The stellar nurseries are all cold and empty. This galaxy is a museum piece, preserved in a state of arrested development for nearly the entire age of the universe. It is a silent world, a city of 100 billion suns that has not seen a new birth in 10 billion years. And this profound, eerie stillness, this state of being red and dead, is the direct consequence of the monster it holds within. As we draw closer, the true nature of the anomaly begins to reveal itself. The stars in NGC 1277 are packed together with incredible density, orbiting the galactic center at tremendous speeds. The motions of these stars serve as a cosmic scale, allowing astronomers to weigh the unseen mass at the core. And the number they found was staggering. The standard model of coevolution predicts a relationship, a delicate balance. Our own Milky Way supermassive black hole, Sagittarius A, is a respectable 4 million times the mass of our Sun, yet this accounts for a mere fraction of a percent of our galaxy's total mass. In the nearby Andromeda galaxy, the central black hole is larger, perhaps 150 million solar masses, but it too adheres to the expected ratio. These are black holes that grew with their galaxies, in concert. NGC 1277 obliterates this rule. Its central black hole weighs in at an estimated 17 billion solar masses. It is one of the most massive black holes ever discovered, a true behemoth of space-time. Its event horizon, the point of no return, would stretch out far beyond the orbit of Pluto in our own solar system. Light itself cannot escape its grasp. But it is not its absolute size that is so shocking, it is its size relative to its host. This single object, this shadow of pure gravity, makes up an astonishing 14% of the galaxy's entire stellar mass. If we consider only the central bulge of the galaxy, the dense sphere of stars at its heart, the black hole accounts for 59% of the mass. It is a gravitational core so dominant that the galaxy around it feels less like a home and more like a fragile, luminous shroud. This is a system not in balance, but in subjugation. The galaxy does not host the black hole. The black hole permits the galaxy to exist around it. This profound imbalance begs the question, how was this monster born? And in its birth, did it condemn its own galaxy to an eternity of silence? To contemplate the heart of NGC 1277 is to contemplate a force that defies easy analogy. We call it a black hole, but it is not a hole. It is the most extreme concentration of matter and energy possible, a point where gravity has overwhelmed all other forces of nature. The 17 billion suns worth of mass contained within it are crushed into a singularity, a region of infinite density where our understanding of physics breaks down completely. Surrounding this unknowable point is the event horizon, a perfect, spherical boundary of pure shadow. It is not a physical surface, but a threshold in space-time. Anything that crosses it, a star, a planet, a photon of light, is irrevocably lost to the universe outside. The gravity of this object is the organizing principle of its entire galaxy. The 100 billion stars of NGC 1277 are not merely orbiting a common center, they are tethered to this single, titanic object. Their frantic, high-velocity paths are a direct measure of its terrifying influence. If we could witness it, we would see space-time itself warped into a profound gravitational vortex. Light from distant stars would bend around it, creating distorted, ghostly images. Time itself would slow to a crawl near its edge, a phenomenon predicted by Einstein and confirmed by observation. A clock near the event horizon would tick infinitely slower than one far away. An eternity for the universe could be a fleeting moment for an object falling in. This is not a passive entity. In its youth, it would have been a quasar, the most luminous object in the universe. As gas and stars from the protogalaxy spiraled into it, they would have formed an accretion disk, a swirling vortex of matter heated to millions of degrees by friction and gravitational shear. This disk would have blazed with the light of 1 trillion suns, outshining the entire galaxy around it. It would have launched colossal jets of energy and radiation, twin beams of incandescent plasma traveling at nearly the speed of light, stretching for millions of light-years into intergalactic space. The heart of NGC 1277 was once the most violent and energetic engine imaginable. But now, it is quiet. The fuel has run out. The quasar has faded. All that remains is the silence, the darkness, and the unyielding gravity. It is a sleeping giant, a relic of a more ferocious era of the cosmos. Its silence is the key to its past, and the reason for its galaxy's strange, petrified state. The clues all point to one stunning conclusion: NGC 1277 is not a product of the modern universe. It is a pristine relic, a fossil from the cosmic dawn, a galaxy that has remained almost entirely unchanged for over 10 billion years. In the early universe, just a few billion years after the Big Bang, the cosmos was a very different place. It was smaller, denser, and far more chaotic. Gas was abundant, and the first generations of galaxies were forming in a furious, disorderly rush. These primordial galaxies were not the grand, structured spirals we see today. They were compact, messy, and intensely productive, converting vast reservoirs of hydrogen and helium gas into stars at a prodigious rate. It is now believed that NGC 1277 is one of these primordial galaxies, preserved for our study. Its stellar population tells this story with unwavering clarity. By analyzing the light from the galaxy, astronomers can determine the age of its stars. In NGC 1277, they are all uniformly ancient. They were all born in a single, titanic burst of star formation that started around 12 billion years ago and lasted for a brief, frantic period of perhaps only 100 million years. In that short window of cosmic time, all of the galaxy's gas was consumed, forged into the 100 billion stars we see today. And then, abruptly, the process stopped. The stellar factories went silent. The nebulae vanished. The galaxy was quenched, its life-giving supply of gas seemingly erased from existence. For the subsequent 10 billion years, it has simply aged. Its most massive stars, which burn hot and blue, exhausted their fuel and exploded as supernovae long ago. Only the long-lived, smaller, cooler red and yellow stars remain, lending the galaxy its distinctive, ghostly red color. It is a snapshot of a bygone era, a single frame from the universe's chaotic childhood. The question then becomes, what could possibly be powerful enough to halt the evolution of an entire galaxy in its tracks? The answer lies in the disproportionate shadow at its center. The oversized black hole is not just a curiosity, it is the murder weapon. Let us travel back in time, to the dawn of galaxies. A massive cloud of primordial gas and dark matter begins to collapse under its own gravity. At its heart, a seed black hole, perhaps born from the collapse of a colossal first-generation star, begins to grow. In the dense, gas-rich environment of the early universe, this growth is exponential. The black hole feasts, pulling in streams of cold gas, swallowing stars, merging with other, smaller black holes. It grows far faster than the galaxy around it. The normal, symbiotic relationship is broken from the very beginning. The black hole is not growing with the galaxy, it is outcompeting it. As it gorges, its accretion disk ignites. The quasar at the heart of the nascent NGC 1277 switches on, blazing with unimaginable power. This is the moment of transformation. The intense radiation and energy pouring from the accretion disk, a process known as quasar feedback, acts like a cosmic superweapon. It creates a galactic-scale shockwave, a hurricane of energy that blasts through the entire galaxy. This cataclysmic outflow heats the remaining gas to millions of degrees and violently ejects it from the galaxy's gravitational grasp, launching it into intergalactic space. In a cosmically brief period, the galaxy is scoured clean of all its star-forming fuel. The black hole, in its gluttonous and rapid growth, has effectively sterilized its own home. It has choked its own cradle, ensuring that no new stars can ever form. The starburst that had been raging across the galaxy is extinguished, not because the fuel was used up, but because it was violently removed. The quenching is sudden, total, and permanent. The quasar itself then fades, its own fuel supply now cut off. The galaxy is left in its current state, red, dead, and dominated by the very engine of gravity that arrested its development. This story of a runaway black hole provides a perfect explanation for NGC 1277's bizarre properties, its ancient stars, its lack of gas, and its impossibly massive central object. It is a victim of its own heart. But this violent birth and sudden death is only half the story. To become a preserved relic, a galaxy must also be protected from the corrupting influence of the present. The Perseus cluster, as we have seen, is a place of constant interaction and merger. A small, compact galaxy like NGC 1277 should have been shredded or swallowed by its larger neighbors billions of years ago. So why does it survive, pristine and untouched? The answer lies in its motion. NGC 1277 is not a sedate resident of the cluster, it is a high-speed interloper, careening through the intracluster medium at a staggering velocity of more than 2 million miles per hour. It is moving so fast that it effectively avoids long, drawn-out gravitational encounters. It does not have time to merge with other galaxies, it flies past them too quickly. This incredible speed also protects it from accreting new gas. As it plows through the hot gas of the cluster, the immense pressure of its passage, a phenomenon known as ram pressure, strips away any wisps of gas it might otherwise capture. Its velocity acts as a shield, deflecting the raw material that could have potentially reignited star formation. It is trapped in a state of perfect preservation, isolated by its own momentum. This raises another question: where did it get such an incredible speed? Its trajectory suggests it may have been part of a smaller group of galaxies that recently fell into the Perseus cluster for the first time. It is a newcomer to this violent metropolis, and its high velocity is a remnant of the gravitational energy it gained during its long fall into the cluster's deep potential well. It is an immigrant from a quieter part of the universe, now on a high-speed tour of a galactic war zone, its ancient nature protected by the very speed that makes it an outsider. This combination of a violent, self-limiting birth and a subsequent high-speed, isolated journey is what makes NGC 1277 a perfect time capsule, a direct window into the conditions of the cosmos more than 10 billion years ago. The existence of a single object like NGC 1277 has profound implications for our understanding of the universe. It is a beautiful, terrifying outlier that forces cosmologists to rethink the neat and tidy models of galaxy formation. The long-held theory of coevolution, where galaxies and their black holes grow in a balanced, lockstep manner, is clearly not the whole story. NGC 1277 proves that another path is possible, a path where the black hole grows first, and grows to such a monstrous size that it completely dominates and stunts the growth of its host galaxy. This suggests that in the primordial universe, the conditions were ripe for the formation of these overmassive black holes. Perhaps the gas was colder and denser, allowing it to flow more efficiently to the galactic center and feed the growing monster. Perhaps the mechanisms that regulate black hole growth in the modern universe had not yet fully developed. NGC 1277 is a piece of evidence, a fossilized clue, that the universe's youth was a far more imbalanced and violent epoch than the relatively quiescent cosmos we inhabit today. It represents a different mode of creation, one of extreme, runaway growth followed by sudden, permanent death. It also forces us to reconsider the upper limits of how large a black hole can be relative to its host. Before NGC 1277 was studied in detail, its properties were considered physically impossible. It stands as a monument to the fact that the universe is always more creative and more extreme than our models predict. It is a humbling reminder that for every rule we uncover, the cosmos is likely to present us with a stunning exception. These relic galaxies, though rare, may be the key to understanding the very earliest stages of cosmic structure formation. They are the missing link between the smooth, uniform universe shortly after the Big Bang and the complex, structured web of galaxies we see today. Each one is a Rosetta Stone, allowing us to translate the faint light of the past into a new understanding of our cosmic origins. What, then, is the ultimate fate of this silent, speeding ghost? Its journey is one of profound loneliness, a slow, inevitable fade into darkness. For trillions of years to come, it will continue its frantic rush through the Perseus cluster, its trajectory bending to the will of the cluster's immense gravity but never settling into a stable orbit. It will remain a solitary wanderer. On board, its 100 billion ancient stars will continue their long, slow process of stellar evolution. One by one, over timescales that dwarf the current age of the universe, they will exhaust their nuclear fuel. The smaller, red dwarf stars, the longest-lived of all, will slowly cool and dim, becoming black dwarfs, cold, dark cinders of crystalline carbon and oxygen, no longer emitting light or heat. The galaxy will grow dimmer, its reddish glow fading to a spectral infrared whisper, and then to nothing at all. Without any gas to form new stars, there will be no renewal, no rebirth. The light of NGC 1277 will go out. All that will remain is a silent swarm of stellar corpses and cold planets, all bound in eternal orbit around the colossal shadow at the center. The black hole itself, the architect of this fate, will persist. Through Hawking radiation, it too will eventually evaporate, but the timescale for a 17 billion solar mass black hole to disappear is almost beyond comprehension, many trillions of times the current age of the universe. For all practical purposes, it is eternal. It will be the last remnant of NGC 1277, a silent, gravitational tombstone in a dark and empty universe. The story of this galaxy is a powerful allegory for the universal principle of entropy. It is a system that had a brief, brilliant flash of creative energy, which then gave way to an eternal, unchanging state of slow decay. It is a glimpse into the far future of the cosmos, a heat death in miniature, where all the lights go out and only the gravity remains. We began our journey with a mystery, a cosmic imbalance, a galaxy that broke the rules. We traveled across hundreds of millions of light-years to a violent city of galaxies, and zoomed in on a silent, reddish ghost. We have uncovered its story, a dramatic tale written in the language of starlight and gravity. NGC 1277 is a relic from the dawn of time, a galaxy whose life was extinguished by the very thing that gave it form, its own impossibly massive heart. In a furious burst of creation, it forged all of its stars, while its central black hole grew to monstrous proportions. That black hole then unleashed a torrent of energy, scouring the galaxy of its future potential and freezing it in time. Now, protected by its incredible velocity, it journeys through the cosmos as a perfect fossil, a direct link to the universe's violent infancy. It teaches us that the cosmos is not always a place of balance and harmony, that sometimes creation is a self-limiting act, and that the shadows can, in fact, outweigh the light. It is a profound and somber tale of power, of consequence, and of an unimaginably long and lonely future. As we pull our gaze back from this single, strange galaxy, and return to the familiar scale of our own world, we are left with the echoes of its silent story. A story of a beginning so violent it precluded any middle, and an ending that will stretch into near eternity. What would you have done if you could witness it? To stand on a planet orbiting one of those ancient, dying suns, to look up at a sky where no new stars have been born for 10 billion years, all while feeling the inescapable pull of the silent, waiting darkness that fills the heart of your galaxy. What would it feel like to know you are living in a museum piece, a ghost of the universe's fiery past, forever falling toward a quiet eternity?